So actually, I was an evangelist in Microsoft for more than 10 years. And evangelist, by the way, is a great job. You travel, you give talks, you live at the expensive hotels, and they pay you for this. But now, for the last year, I switched my role to a software engineer, and it's nice to be programming again. We do some pilot projects with partners. We did a few projects with Acronis that I will be telling you about today. And actually, I would like to start with thanking the organizers for inviting me here, not only because it's a great conference with great speakers, but also because I really love Bulgaria. I go here like for the last 5-6 years with my daughter every summer to the junior youth camp. You can recognize maybe some of you the places near Varna, Pobiti Kamni, the place which we love a lot. And it's a pleasure for me to be here. And I would start by talking about artificial intelligence overall and then move to security towards the end. And I would start with obvious things. You know that I want to make a thesis that artificial intelligence is something which will change the most the way we live. Like, for example, in the beginning of the century, the invention of internal combustion engine changed the way that transport worked. And, you know, like those are the streets of New York, which changed completely in 10 years. Now the process which changes our lives is called digital transformation. And I will just give you one example. Example of McDonald's. I think after lunch I can show the picture like this without causing any hunger in the audience. So McDonald's, you know, they have the thing called McAuto where you drive with a car, you order, and you pick the food shortly afterwards. And in US, it's very expensive to put the American worker in this McAuto, and instead they started putting a microphone, and you are talking with a remote operator somewhere in India when you are ordering food. And this case is described in the book called The World is Flat by Thomas Friedman. It's like more than 10 years old. They started doing it a long time ago. And this is the beginning of digital transformation. And that's it's clear why it's called digital, because it's easy to digitize the voice and take it to another part of the planet where it will be processed. Nowadays, actually, we can live even without the operator. Here is the project which Microsoft worked with McDonald's maybe about more than a year ago. And the project was to basically automatically recognize the order. And you can now hear what a typical person in McAuto window hears. It's not a very clear sound, as you can understand. It's actually, even for a human being, very hard to understand. But a computer can do it even better than a human being. And actually, this problem is not very complicated because the problem domain is very, it's very narrow, right? Nobody would speak about the meaning of life with the McDonald's booth. Everybody would be just ordering cheeseburgers. So that's why it's possible to solve this problem quite accurately. But in general, if you talk about the human parity, how good is artificial intelligence comparing to humans, in 2016 there was a paper by Microsoft Research which showed that there is a human parity in speech recognition. They made an experiment which demonstrated that computers can recognize voice as accurately as humans. And the same was done in 2015 with respect to images. It doesn't mean that computer can see better than a person, because a human being, your eye is a very sophisticated device. You can look in different places, you can zoom in, focus on something. But if you just take a simple task, you need to recognize, for example, road signs. And you are given 1,000 road signs, and you need to recognize them and sort them, put them into different categories. Of course, the human being would get bored towards the middle of this exercise. Imagine you have to look through 500,000 road signs. But the computer doesn't get bored, and that's why overall computer shows the same accuracy as a human being. And all of those things, by the way, are very recent. When we started talking about the progress in computer vision, for example, there is a big competition called ImageNet, where every year scientists, they compete for the problem of image recognition. And for example, in 2010, the error was something like 30%. In 2010, if you asked a researcher whether it would be possible for a computer to recognize a cat from a dog in the next 20 years, they would say no. It's not possible to do it accurately enough. But then people started using like better, deeper neural networks, deep learning in 2012, and since then you see that the accuracy starts improving very rapidly until it achieved the human level in 2015. So all these things I'm talking about are very recent. You can see the example like this is the algorithm from 2016, which can recognize objects in video in real time. Before 2016, the same process took about 1,000 times longer because the way it worked, you needed to run the neural network many thousand times through the image. And in 2016 came the algorithm called YOLO, which does it in one pass, just basically one computation through neural network, and you get all the bounding boxes, all the images. And that's why you can do it in real time, like shown in this video. Yeah, I will have to stop, even though it's fascinating looking at the video like this, but you can have a look yourself on the internet. So the research, the fast research is powered by several things. First of all, there is a lot of computing power because the cloud now is available, and also because, you know, now with the crash of cryptocurrencies, there would be a lot of cheap GPUs on the market probably, which are very good for doing AI research. Also, there is a lot of data. In general, you know that the amount of data doubles every year or so, so we're getting much more data overall, and more data means we are able to do more experiments and we can do better artificial intelligence models. And all that powers the new scientific research, because right now a good paper typically involves the link to GitHub where you can download the code and you can start actually playing with the code and testing your own ideas and then publish it again. You probably know that there is an application called Prisma, which changes the picture into a painting. There is a iPhone application. It came half a year after there was a paper published on this thing called neural style transfer. And it implements exactly the ideas from the paper, but in the application. So those things can get into production really fast. What's very important to realize is that with artificial intelligence, we have to change the way of thinking about what is important, what is like our know-how. Because data becomes more important than algorithms. If you take, for example, the domain of search, like Google and Microsoft, they were competing for better search accuracy for many years. And in the competition, the algorithm is important because the better you design the search algorithm, the better accuracy would be. And with data, it's a different story. If you want to design an algorithm to determine the emotions on the human face, the algorithm is pretty much well known, but you need the data set. And data sets, they are becoming really important for achieving those tasks. And also, this way of thinking about data and not about algorithms is required. So general understanding of machine learning, of artificial intelligence is really important for developers nowadays, and specialists who are really specializing in machine learning, they are really rare. You know, everybody is looking for them, and they are hard to find. So to tell you a little bit about why Microsoft is talking about AI. Microsoft is now becoming more and more a cloud company. And in the cloud, of course, you can sell virtual machines. That's not interesting. I mean, everybody does that. But also you can sell certain kind of specialized services. And we believe that a lot of workloads in the cloud would be AI workloads. And that's why we think it's really important to provide better and better services for developers to use AI. And that is what's called democratization of AI. And I will talk about that in a moment. And there is also, of course, AI is now being put into very many Microsoft products. For example, do you know any Microsoft products which have AI built in? Anyone? I showed the Skype translator on the slide, so definitely you probably know that Skype translator can translate conversations in real time from a language to another one. But also the products like this, for example, PowerPoint. It has AI built in. For example, if I take the slide and I want to insert a picture from like internet or from my computer. Let me make this slide more beautiful by putting a picture of a kitten. So if I insert the picture, automatically the service is called and it creates the textual description. You see a close-up of a cat. This description was derived from the picture. It was not like found anywhere. It's just the computer describes what it sees in the picture. And also there is a thing called this design ideas. I can design this slide in one click like this, and it would look beautiful. You know, the designers, I don't need designers anymore, because artificial intelligence can do slide design, well, not yet better than humans, but at least to some point. I do that, by the way, from time to time, use this design assistant. But for us, since we are at the developer conference, you are probably more interested in what Microsoft does for developers. And with AI, as with any modern technology, we distinguish whether it can be used in the cloud or at the edge, in the device. So I kind of classify the technologies between the cloud and the edge. Cloud means Microsoft Azure. Edge means different devices running either Windows or not Windows, any other operating systems. And there are some technologies which are very easy to use. For example, cognitive services, those are already pre-trained models available in the cloud and ready to be used. For example, there are very often typical tasks which need to be solved, like finding objects in the image or describing the image with the text, or maybe doing text-to-speech and speech-to-text conversions, things like that. And those are available as the services which you can use either in the cloud, or you can use them on the edge by getting the Docker container with the running model, which you are able to use in your application. So if you have the task like this, you can really easily solve it without any AI knowledge, just by using the cognitive service. There are also some other technologies for like beginners, for entry-level people. Azure ML Studio allows you to experiment with machine learning models in a very intuitive and graphical way. And because I don't have much time, I will not show you the demo. But I encourage you, if you want to experiment with machine learning and you have not done nothing about this before, just Google it, or should I say Bing it in the internet, and look for it, and you will see nice videos with tutorials. Then, of course, there are just raw computing resources. Like every cloud has virtual machines, and if you need to train your model, you have the already pre-built virtual machine images which you can use on the machines with the GPU to train the model. I use this technology every day. And if you need larger scale compute, there is a very interesting technology called Azure Batch AI, where you can get the cluster of machines at a really low cost. Because in the cloud, you know that Microsoft is waiting for people to get virtual machines in the cloud. And while it's waiting, there are a lot of machines which are not used. And we can sell them at a very low price, just so that they are not, stay there without any workloads. So Azure Batch AI takes advantage of those unused machines. They offer it at a very low price, and you can just train the model on the cluster with this. And the model can then be deployed either in the cloud or on the edge. And finally, if you want to design really a large-scale AI service, for example, like the one I will be talking about later on, like if you want, for example, to build AI capabilities into products like Acronis products, you would need to set up really big infrastructure in the cloud. And you can, of course, do that with virtual machines, but there is also a thing called Azure Machine Learning Service, which already does this for you. So if you have really large-scale problem, you can use also technologies for that. They are a little bit more complicated to use than just virtual machines, in the sense that if you have scaling problems, you have a lot of things to worry about. But they are still there, and Microsoft shares its own experience of running machine learning models at scale. Because definitely inside Microsoft, all those services which I showed you, they are being run on really big scale computing clusters. There is also a technology coming up which is using machine learning models on FPGAs. FPGAs, they are chips which are programmed once, and then they can be used many times for computations. So if you, for example, if you want to put the service at heavy load with a really energy efficient way, FPGA is the way to do it. It's still in the early stages of development, but already now you can use this technology to run some image recognition tasks. I will talk a little bit about cognitive services. So cognitive services, as I mentioned, they do some typical tasks. For example, if you take an image, they can produce you the English description like I showed you in the PowerPoint, but you can also use this functionality in your own application. What you need is just one call to the cloud, REST API. You give the picture, and it gives you back the description. It also gives you back different tags for the objects which are present in the picture. And this is very useful, for example, if you have the large image archive and you don't know what's there, you can index it very easily. You can get the keywords, you can get the faces of people, and organize the search within this image archive very easily. We did a project like that with one media agency because this problem is really typical for media. And you can, by the way, you can try the way it works. Another problems which typically arise are people emotions, age, emotions, and so on. You can see how it works. I have the bot in Telegram, which is called Oh My Mirror Bot. And if you have Telegram, you can try it yourself. If not, I will show you how it works. So basically, I would take my Telegram and take a picture of the audience, like if this part of the audience can smile for me, please. And I apologize for those whose age would not be correctly understood, because as you probably understand, it doesn't work very well with small faces, because like if I take a picture like this, each face on the picture is a few pixels, you know, like it's not really large, so it's difficult to accurately determine anything. But still, you see, we can prove that most of the people are happy during the presentation, which is a nice thing to show you. And not everybody is recognized, because this technology, I mean, it can recognize something like 24 faces, I think. It has some limit. And to write this bot, by the way, is a very simple exercise. And normally, if I speak for more than 30 minutes, I show how to do it right on stage, because it's just a few lines of code. Commercially, for example, how it can be used, The Economist, when there were presidential debates in the US, they showed like broadcast on their site together with these emotion graphs. And without following the debates, you can see how the debates go. You know, you can see the emotions, and you can understand more or less like who is saying what. We use this technology at our summer camp, for example, for kids. We made the system which we put during lunch and breakfast and supper in the Mensa, and they were able to take their photographs like in a funny way. So we collected a lot of faces with emotions, and because we also built in the face recognition using the same kind of services, we were able to distinguish photographs of different children, and we could prove that happiness of children rises, you know, as the time passes, and we can show to every parent the printout of the happiness of their kid during this camp. And this is scientifically proven fact that kids are getting better during summer camps. Instead of waiting them, you know, that at the old times they used to wait, and the more weight the child gains, the better. And the more happiness he gains is definitely the better way to measure it. Another demonstration I want to show you really briefly is the service called Custom Vision. So Custom Vision allows you to train your own model on your own images if you need to recognize or to classify different images. And it's as easy as uploading pictures to the website, customvision.ai, and then it builds the model automatically. So one example here is I built this example for recognizing gestures, so thumbs up versus thumbs down. You upload a bunch of pictures, and then you get the model. Here you see the precision of the model is pretty good on this number of pictures. And then you can export the model, you can download it and run it on the local device, or you can run it as a service in the cloud. For example, if I take like the image from the internet, oops, not this one, but the, like, for example, this one, a human being. I take the URL, and I can test the model. And it recognizes, let's say, up gesture with 99% probability. And if you want to run it locally, for example, on Windows platform, there is a technology called Windows ML. Windows ML is really easy to use in the Visual Studio. You just drag the model. The model is exported as the file with the ONNX extension. ONNX stands for Open Neural Network Exchange. It's a format introduced by Microsoft and Facebook and some other companies, an open format for exchanging information of machine learning models. If you drag this to Visual Studio, it will automatically generate the C# file, which can be used to call this model. The only problem is that the name of the classes in the file, they are not really descriptive. So if you want to use it in practice, you better rename it. So I have the renamed version of this, which I call from, basically from this application. This application takes the picture from the camera. So I can test the model in real time. If I provide the gesture like this, it tells me it's an up gesture. This is the down gesture. So you see that it's very easy to start using this with the cognitive service. Cognitive services can be used for different scenarios. For example, we did one project with Acronis, which is called Semantic Search, and the idea was to provide the textual, like human language interface to knowledge base. A knowledge base contains articles about different software products with the known problems. So we wanted to do basically the website where the user can query it in the real language. So first attempt which was done, we tried to recognize the intent of the query. And to recognize intents, it's a typical machine learning problem. But there is also a service which does that, which is called LUIS, Language Understanding Intelligence Service. The only thing you need to do, you provided the sample of phrases and the corresponding intents. And it can capture like what the user wanted. Like if you define certain kind of typical intents, and certain kind of typical entities, for example, software product names, you train the model, and it gathers this information from the input. And to find the relevant articles, we used another service called Azure Search, which is basically Elasticsearch, but available in the cloud. So we indexed this corpus of knowledge base in the clever way, like putting the product names in one field and attaching certain kind of weights to different fields. And then basically, with a simple query rewriting and extracting the entity names, we were able to formulate the Azure Search query and provide the link to the relevant article. So the project like this can be put together like in about a week by a small team of experts. Another project which is not directly related to security, but I just like to tell you about it because it's very interesting, is recognition of events and videos. This requires more complicated AI techniques, like we had to train everything from scratch. But the idea was to recognize different events, and we focused on collisions in Formula E. So basically, this is the typical collision when you have cars crashing at each other. And it's very easy to recognize visually in this case, where you actually see some pieces falling apart. But sometimes it's very subtle, you know, when cars, they just come close and touch each other. Even a human being cannot accurately say if it's a collision or not. So we wanted to recognize collisions, and what we did, first of all, this problem is kind of complex because it's on one hand, it's a spatial problem. You can see pieces falling apart. Probably it means a collision. So you can look for pieces in individual frames. But it's also a time-based problem, because when cars are coming together, probably there would be a collision shortly. So you need to look in the spatial domain as well as in the time domain. So what we did, we took the 5 seconds intervals of the video, and for each interval we wanted to predict the probability that there is a collision there. And because you cannot gather a really big data set, you know, collisions are not very often things which doesn't happen very often, because you ruin the car, you know, it's an expensive exercise to do a collision. So we were able to gather something like 300 videos with collisions and about 300 videos without collisions, and to use that as a data set. And because it's a small data set, we needed to somehow come up with really nice features which would show you that the collision happens or not. And we used a technology called optical flow, where you take two frames, you compare them, and you have the vector field of how different pixels moved from frame to frame. So this is the result which shows that in the optical flow you can see the traces of objects moving really easily. And then from the traces you can build the histograms. Like we switch to polar coordinates, so basically we have the magnitude of those vectors and the direction, and build histograms. And in the histograms, for example, we have peaks corresponding to objects moving in different directions. So it should be easier to recognize collision, because like if you have two objects moving towards each other, probably it would contribute to the fact that there is a collision. Then we also noticed that this optical flow does not give you, it does not always track a car. Sometimes it tracks, you know, camera movement or something like that. So we switched to another version of optical flow, which first finds the car in the video, and then it traces the car. So we were able to get the traces like this, the trajectories of the moving car. And then from those trajectories, we also produced the histograms. And finally, we also used the, some kind of encoded version of video frames. We used VGG16 embeddings, if it tells something to people here, I don't know, as a third approach to detecting collision. So if we use just one approach, we were able to get the accuracy of about 70%, 75% of the model, which is not really great, because like 50% accuracy means you do a blind guess. And 75% means you do a little bit better than a blind guess. But then what we did, we combined those two approaches together into one big, huge neural network model, which took like the whole night to train. And this produced something like 95, 94% accuracy on our data set. It's still not really clear whether it's a good result or not, because you need, whenever you have the problem like this, it works on one data set, but then like lightning conditions change and it stops working. That can also happen. But that's the first approach which we did toward this problem. And if you want to know more, we have the nice video cast about this, ak.ms/teamcast. It's like half an hour or maybe an hour long video which describes this in detail. And also there is a code on GitHub which shows you how we did it. We also developed a nice Python library for doing this kind of research, but I will not talk about that. So now coming towards the actual topic, you know, using AI for security, I will just focus on one problem, like malware detection, and to see how AI can be applied here. And there are basically two big approaches here, which is static analysis and dynamic analysis. In static analysis, you look at the executable and you look at the code. Like, are there any patterns in the code which are typical for malware? And the way to apply AI and machine learning to this is basically to take a lot of samples and to train your model. But to do this, you need to extract some kind of features from the executable. You do not give the whole source code. You basically try to find some nice features which could tell you, which are typical for malware. For example, is the executable compressed or not? What's the size of different blocks in the executable? Like, what's the distribution of entropy in the file? Things like that. And with that, you can train the traditional machine learning model. Also, there is an observation that if you build like a map, if you take a file and build the map of the entropy of bytes, you can see like the human being can differentiate between malware and non-malware because the patterns would be different. So you can also use traditional machine learning techniques for image recognition, namely convolutional neural networks, CNNs, applied to those kind of images extracted from executables. Then you can also, like more complicated techniques would involve sequence analysis. Like, what is the sequence of commands which are typical for malware? And the same can be applied, sequence analysis can be applied to stack traces during dynamic analysis, where you actually analyze the sequence of calls that the program makes during execution. This is like static analysis is better because you can take the executable and tell before running it whether it's bad or not. With dynamic analysis, you need to run the program, and then when it runs, you can say, oh, that was a bad program. I shouldn't have run it. Or you can, of course, stop it at the early stage, but still it requires you to run the executable somehow, either on your computer or in the sandbox. So the way typically sequence analysis is done using neural networks is called recurrent networks. And the idea is that you have the sequence, like this sequence of x0, x1, and so on. And you pass this sequence like one by one element by one, into a neural network. Like you pass it and you get some kind of state. Then the next network takes this state and takes the next element of the sequence and produces another state, and so on. And at the end, it produces the final vector. So it converts the sequence into a vector, which represents somehow the nature of this sequence. And then this vector is put into a classifier, which in the end tells you whether it was a good sequence or bad sequence. So that's the rough idea of how sequence analysis, how recurrent networks work. They have a lot of problems. The recurrent networks are difficult to train because they tend to forget the beginning of the sequence. Therefore, there are some more complicated recurrent networks. LSTM or GRU are the two most common approaches, and I will not go into detail here, but so that you know, this problem is really typical for language understanding and things like that. And one of the projects that my colleagues at Microsoft did with Acronis is to apply a really modern technique called hierarchical attention networks to analyzing both dynamic analysis of the sequence of Windows API calls that the process makes and static analysis analyzing the source code. And also there is the link here which gives the complete description of this project. The idea of attention networks is that when you have a sequence, certain parts of the sequence, they are more important than the others. So for example, if you take the executable, maybe like a certain section towards the end of the file is more important to classify whether it's a bad file or not. And this hierarchical attention networks, they learn automatically which parts of the file are more important in taking the decision. So there are essentially, here there is a traditional recurrent network. It then produces kind of this state vector, and this state vector is kind of multiplied with the attention vector. This is the rough idea. And this happens, first of all, at the word level, if you think about text. And then for each word, you get a kind of vector, which you then analyze sequence of those words on the sentence level, and you get the final result. So this can be also applied to executables, and the details are in the paper there. And those technologies, they are already used in practice, like not maybe exactly those neural network approach, but in general, ML approaches to security, they are used already in the Acronis product in the true image. This technology is called active protection. And active protection is basically tries to detect the typical patterns of how software accesses files. And it can detect like ransomware which from those patterns. The way it works, you have of course, you need the cloud. You take a lot of data from, first of all, from the experiments. You have a lot of images, and you run typical problems, and you collect the information about how they access files. And then you run malware. You get those data set with good and bad programs. You train the model, and then this model is deployed on the client, on the actual true image instances for the users. And then more data is collected, model is retrained, and this is how this whole process improves constantly. So this is something which is already in place, and just the work is being done on how to make the models more complicated, like to use more sophisticated neural networks for classification instead of traditional machine learning techniques. So this was the use of AI for security, and there is also another part of the security question is how secure are neural networks themselves. And it turns out that AI presents different challenges to security. For example, there is a thing called adversarial attacks. When you train the neural network, which can distinguish between different animals, and then you add some kind of noise to the image, and the image is suddenly classified as a completely different animal. And this noise is not visible. So for the human being, you would not notice the difference. But if you know the architecture of the neural network, you can design this image which would be wrongly classified. And this is very serious, by the way, because it can look simple from this example, but for example, the same thing can be done with the road signs. If you train the network of the self-driving autonomous vehicle to recognize signs on the road, and then you just put a little bit of, adhesive tape to the sign, and it is recognized as a completely different sign. For example, in this case, instead of stop, it is recognized as the speed limit, 100 kilometers. So the car would basically crash if it doesn't recognize the sign correctly. So it's a serious issue which has to be considered. And another issue is that neural networks now can produce images which are indistinguishable from real-world pictures. In this example taken from the paper, the first row are real photographs, and all photographs below are computer-generated. So you can generate fake people, you can generate real people faces in fake situations, and this would be almost indistinguishable from real pictures. And this is also the security issue, like for all news companies, because you can find the picture on the internet which compromises someone, and there is no easy way to prove if it's right or wrong. So AI changes the security landscape. Some things we still need to understand how to deal with. And in general, I think the main thing which I want you to get out of this talk is that learning some AI and ML techniques is crucial for all developers, so I encourage you to do that. And thank you very much for being here, and I would welcome your questions if I have time.
I believe it was a great presentation. Thank you. And we have questions for 2 or 3 questions. Please, guys, any questions? Yes, here, Misha.
Hello. Is that software tested for blind people, or I guess can help blind people to recognize people, places,
yes,
things?
It is used for blind people, and there is an application called Seeing AI in the marketplace, which you can install on the phone, and you can actually take the picture with the phone, and it will tell you what's around you. And there is also a very nice video from Microsoft. I used to show it in the longer presentations, where we have the blind person working in Microsoft who designed the special glasses which can do that. So,
thank you. Other questions? Yes, here.
Hi, thank you for such a great presentation here. My question is about how do we secure the input data which will be used as a data model for the machine learning algorithms, especially when the machine learning algorithms are quite popularly available, like for example TensorFlow and things like that. So how do we secure the input data?
Yeah, I think that's a great question, and I would like to say it's not a problem of machine learning experts, because machine learning experts require data. I think basically you can use all the traditional ways of ensuring that nobody can get interfere with the data. But the problem is really huge, because if somebody is able to inject, for example, wrong data in the training data set, you have no means to notice that, because you cannot possibly look through the whole data set yourself. So there is a problem, and there are some ways probably which can be done to eliminate it. For example, there are techniques called like anomaly detection, and you can say that, for example, if data which is injected somehow is controversial and is completely different from the data set, you can probably detect it somehow automatically. But it's still not an easy task.
Question here.
Hi. It was interesting, very interesting presentation.
Thank you.
All of examples that you present was so-called supervised learning.
Right.
Can you share something in unsupervised learning area that Microsoft and you develop in the recent years?
Well, personally, I did not have the projects like that, because most of the problems which we face, they are supervised learning. With unsupervised learning, I mean, there are a few like well-known examples, like for example, bots which were trained on conversations like with each other and things like that. it's a kind of more difficult. Unsupervised learning is typically a more difficult problem because you need you need to devise the sandbox to do that, and also you need a lot of training time and training examples. So I do not have existing projects to share, I think. Yeah.
What about AlphaZero?
AlphaZero, yeah.
Unsupervised learning, but not
Yeah.
Microsoft for now.
Yeah.
I have actually one question to you, probably the last one. Do you think that all IT security specialists should learn AI? And what is the best way to start learning?
Definitely everybody should learn AI. The best way to start learning is probably there are good courses on the internet, and there are some hardcore courses like on Coursera, like machine learning, and courses by Andrew Ng, who is the founder of Coursera. He has the most classical machine learning courses there, which are a little bit hard, but you will also should be able to find some easier examples, and the good way to start with machine learning, as I mentioned, is Azure ML Studio. Just look for it, and there are videos on the internet, because it allows you to start experimenting just by, in a visual interface without learning to program in Python. A lot of software engineers hate Python, by the way, for good reasons.
Yeah. Okay, thank you very much.
Thank
Great
you.
presentation. Thank you, Dmitry.
Thank you.